Hey, it's Alec for the next interactive assignment. So this one, we're looking at the experiment that we were doing is taking gummy bears and looking to see um, how they would react depending on the type of environment they're in as far as liquids are concerned. So the instructions were very simple. Take gummy bears. So we had little gummy bears, and we were to take them and put one in a solution that was just tap water, and then the other solution was going to be water that had that was super saturated with salt, um, sodium chloride. So what I've done is the first time I butchered it, and they did not come out right, so I wanted to try it again. And so I have in front of me for the gummy bears, I actually have 3 cups. I know we were only supposed to have 2. So this is one, and then this is one here. They've been sitting for about 7 hours, I want to say. So since I messed the first one up, basically the result was that the gummy bears both increased in size, and so my assumption is that the one that had salt in it did not have a high enough salt concentration. So in an effort to make sure that I had enough salt, this time around I ended up using hot water to try to help the salt mix, and then I also used hot water for the normal tap water solution as well, which confused me a little bit because when I went to check on them about 2 hours ago, and I told you I did 3. I did one normal tap water solution that was warm water and one that was just regular, just to see what would happen. The one that was the hot normal tap water, it exploded, basically the gummy bear. So in it, I'll hold it up. You can see the red remnants of it, but there is not actually a gummy bear, much of it left. You can see just the very vague shape of maybe just the very inner parts of that chemical makeup being there, but all around in the liquid you can see where that outer barrier has just obliterated itself. It is in pieces everywhere. I will drain out the other 2 though to kind of show the example that was in this video. So let me turn this here a little bit. I'm going to walk back to the sink to drain these out so that I can get the gummy bears out of the liquid. Get a paper towel here. Alright, so I'll start by getting out the normal tap water gummy bear. There we go. And then I'm also going to dump out the one that was in the saltwater solution, which is green. That out as well. So I'm going to angle the camera down just so we can kind of see what we're looking at here. And again, I'll put the cup over here where the one obliterated as well. So angle this without losing it. So on this paper towel here, we have, again, the cup of the obliterated gummy bear. And the reason that occurred, the heat combination with the makeup of the gummy bear, basically it created an environment where it was absorbing water into the gummy bear at a rate so quickly that it filled up past the point that the gummy bear could hold it. So it exploded in the solution. Now if we look at the, back this up here a little bit, the red gummy bear is just a regular gummy bear. Okay, he did not go into any of the solutions. I'm going to pick up the one that was in the salt solution, which is ever so slightly smaller, not much, but as we can see, it did not increase in size at all, like the one that was in the hot water. The one that had the salt concentration remained the same size, maybe a little bit smaller. The only reason it's about the same size is because honestly it's got salt caked onto it. Now I'm going to lift up the gummy bear that was in normal temperature tap water. If I can pick it up, it's pretty squishy because of the added water solution. So we can see there, maybe, the orange gummy bear is significantly larger than the red gummy bear. So it was able to take on much more water. So the question for the video is, why is it that in a regular tap water solution that the orange gummy bear, in my situation, was able to absorb water, but then in the saltwater solution it actually decreased or stayed about the same size? And the reason for that is because the water that had the salt in it created what we call a hypertonic environment. So hyper meaning there was a greater amount of substance outside of the what do we want to call these? Outside of the gummy bear, basically. So because there was a higher substance content outside of the gummy bear, it actually draws out from the gummy bear anything that it can. Whereas in the hypotonic solution, so the one that had just tap water, we saw water would be trying to pursue a balance, would rush into the gummy bear. So if we think about osmosis, that passing of water through a semi-permeable barrier, that is what was taking place with the tap water gummy bear, the orange one. Is we had the gummy bear here, the water's all the way around it, in this area all around, and then the water is rushing into the gummy bear to try to find a balance. Okay, when there was too much of it, it caused the gummy bear to explode, like in my cup. But when we had on the gummy bear and then all around it that salt concentration, the water was actually water does not bond to water if there's a high salt concentration as easily. It's kind of the same concept we have with our lab this week. If the salt is present in the water and it's bonding with the water, so it's dissolved in the water, then those bonds are going to take more effort to break down, and they're not as easily going to be able to flow into the gummy bear. So that's why we see not very much change in size, maybe a little bit of a decrease in size in the green gummy bear. So thank you for your time. If you have any questions, feel free to post under the video, and best of luck, and have a good day.